So in the previous lessons, we learned how to add and subtract vectors, and we saw a couple of examples as well. Now in today's video, we are going to focus more on how to multiply two vectors. Now the multiplication of two vectors can as well be defined in two ways. We have the first one to be the dot product and the second to be the cross product. In this video, we shall be looking at the dot product and consider the cross product in the subsequent videos. Now let's get into today's lesson. So given that we have two vectors, vector A has components A1, A2, A3, and then we have vector B also having components B1, B2, B3. Now the dot product of vector A and B is given as vector A dot vector B, and that is equal to, basically we are going to multiply corresponding components and then sum them up. So we have A1 times B1 plus A2 times B2 plus A3 times B3, and the results after multiplying corresponding components and then adding them up gives a real number, that is a scalar, and hence the dot product is sometimes called the scalar product. So let's take some examples. Given that vector P has components 2, 1, -1, vector Q has components 1, -3, 2, and vector R also has components 5, 0, 2. Now let's find I, the dot product of vector P and vector Q, and then II, the dot product of vector P and vector R. So let's solve this together. Now the dot product of vector P and vector Q, which is given by P dot Q, is equal to, now we have the components of vector P to be 2, 1, -1, and the components of vector Q also to be 1, -3, 2. So basically what we are going to do is to multiply corresponding components and then sum them up. So we have 2 times 1, which is 2, plus 1 times -3, which is -3, and then -1 times 2, which is -2. So let's simplify. 2 plus -2 is 0, and then 0 plus -3 is -3. Therefore, P dot Q is equal to -3. Now let's solve for II. That is vector P dot vector R. Now we have the components of vector P to be 2, 1, -1, and that of vector R to be 5, 0, 2. 2 times 5 is 10, plus 1 times 0 is 0, plus -1 times 2 is -2. And then 10 minus 2 is 8. Therefore, the dot product of vector P and vector R is 8. So basically, this is how to find the dot product of two vectors. So again, let's assume that we have two non-zero vectors, a and b, and the angle formed between these two vectors is said to be theta. So we have 3 points. We have point O, point A, and then point B. Now the vector joining point O and point A is said to be vector A, and that joining point O and point B is said to be vector B, and the angle formed between these two vectors is said to be theta. Now in that case, the dot product of vector A and vector B, which is written as vector A dot vector B, is said to be the magnitude of vector A times the magnitude of vector B times cosine of the angle theta, where theta is less than or equal to pi and then greater than or equal to 0. Now if theta is equal to 0 or pi, then it means that the two vectors are parallel to each other. If theta is equal to 0, then the dot product of vector A and B is equal to the magnitude of vector A times the magnitude of vector B. Now cosine of 0 is equal to 1. So basically cos theta goes to 1, and then magnitude of vector A times magnitude of vector B times 1 is still magnitude of A times magnitude of B. And then if theta is equal to pi, then the dot product of these two vectors, A and B, is equal to negative of the magnitude of A times the magnitude of B, simply because cosine of pi is equal to -1. So what happens if the angle formed between the two vectors is 90 degrees or pi on 2? Now if theta is equal to pi on 2, then the dot product of these two vectors, A and B, is equal to 0, because cosine of 90 degrees or cosine of pi on 2 is equal to 0. And then 0 times magnitude of A times magnitude of B is still equal to 0. Then we say that the two vectors A and B are perpendicular to each other, or better still, they are orthogonal vectors. Now using this same formula, if you are given two vectors A and B and you want to find the angle formed between these two vectors, then basically you say that theta is equal to the cos inverse of the dot product of A and B divided by the magnitude of vector A times the magnitude of vector B. So basically, given two non-zero vectors A and B, this is how to find the angle formed between these two vectors. Now let's try some examples on this. So we have two questions here. Let's try to solve them together. Question 1. If the magnitude of vector A and the magnitude of vector B are 7 and 5 units respectively, and the angle between vector A and B is pi on 3, find the dot product of vector A and vector B. So the dot product of vector A and vector B is given by the formula. We have magnitude of vector A times magnitude of vector B times cosine of the angle theta. Now here we have the value of the angle theta to be pi on 3. The magnitude of vector A is 7. Magnitude of vector B is 5. And then we have this times cosine of pi on 3. 7 times 5 is 35. Cosine of pi on 3 is half. Therefore, 35 times half is 35 over 2. So basically, this is the dot product of vector A and vector B. 2. Find the angle between vector P and vector Q if vector P has components 1, -2, 3, and then vector Q has components 3, -2, 1. Now to find the angle between any two non-zero vectors, we know that cos theta is basically equal to the dot product of the two vectors P and Q divided by the magnitude of vector P times the magnitude of vector Q. Now let's find the dot product of the two vectors. So basically we are going to multiply corresponding components and then sum them up. 1 times 3 is 3. -2 times -2 is 4. 3 times 1 is 3. So we have this all divided by. Now let's find the magnitude of P and Q. So the magnitude of vector P is equal to, we have the square root of the square of the x component plus the square of the y component plus the square of the z component. Now 1 squared is 1. -2 squared is 4. 3 squared is 9. 1 plus 9 is 10. And then 10 plus 4 is 14. Therefore, we have the magnitude of vector P to be the square root of 14 units. So we have square root of 14. Now let's do same for the magnitude of vector Q. So for magnitude of vector Q, we have that equals the square root of, for Q we have 3 square plus -2 square plus 1 square. 3 squared is 9. -2 squared is 4. 1 squared is 1. 1 plus 9 is 10. And then 10 plus 4 is 14. So for the magnitude of vector Q, we also have the square root of 14 units. So let's insert that here. So square root of 14. Now let's simplify. 3 plus 3 is 6. Plus 4 is 10. So we have 10 divided by. Now we have square root of 14 times square root of 14. That is equal to the square root of 14 all square. The square cancels the square root. We are left with 10 divided by 14. Now 2 goes into 10 5 times. 2 goes into 14 7 times. Therefore, we have cos theta equals 5 over 7. Now, since we want to find the value of theta, theta is equal to cos inverse of 5 over 7. And that is equal to 44.42 degrees. So basically, this is the angle formed between the two vectors P and Q. Now let's move on as we discuss the properties of dot product. So given that A, B, and C are vectors, and then X is a scalar, so we have A, B, and C as vectors, and then we have X to be a scalar. Then 1. The dot product of a vector, say A, and itself is equal to the magnitude of vector A square. Now to prove this, the dot product of vector A and itself by definition is equal to the magnitude of vector A times the magnitude of vector A times cosine of the angle theta. Now the angle formed between a vector and itself is 0 degrees, and then cosine of the angle 0 is equal to 1. So basically we have the magnitude of vector A times the magnitude of vector A times 1, and that is equal to magnitude of vector A times magnitude of vector A. Therefore we can simplify this as magnitude of vector A square. 2. The dot product of a vector, say A, and a vector B is equal to the dot product of vector B and vector A. Now by this we say that dot product is commutative. Now let's move on to 3. The dot product of a vector, say A, and a vector B plus C is equal to, basically you can choose to distribute A across so that you have the dot product of vector A and vector B plus the dot product of vector A and vector C, and hence dot product is distributive over addition. 4. The dot product of a vector, say A, and a 0 vector is equal to 0. 5. If a vector, say A, is multiplied by a scalar x, then the dot product of xa and b can be expressed as, we can choose to find the dot product of A and B before we multiply that by the scalar. So that can be expressed as the dot product of A and B, and then we have times x, or better still, we can choose to multiply vector B by the scalar so that we have xb, and then we find the dot product of vector A and vector xb. Now let's move on to 6. If the dot product of vector A and vector B is equal to 0, then vector A is perpendicular to vector B, or either vector A is equal to 0 or vector B is equal to 0. So now let's move on to scalar and vector projections of a vector onto another. So given that A and B are two vectors, then the scalar projection of vector B onto vector A, which is sometimes referred to as the component of vector B along vector A, is given as the component of vector B along vector A is equal to the dot product of vector A and vector B divided by the magnitude of vector A. Now we can simplify this as, we have vector A divided by its magnitude, so that is the unit vector of vector A, that is A cap, dot vector B. So it's simply the dot product of the unit vector of A and the vector B. Now the results after finding the scalar projection of a vector onto another is a scalar. Secondly, the vector projection of a vector, say B, onto A is equal to the dot product of vector A and vector B divided by the magnitude of vector A times the unit vector in the direction of vector A, that is vector A divided by its magnitude. Now we can as well simplify this as the dot product of vector A and vector B divided by, we have magnitude of A times magnitude of A, that is magnitude of vector A square, all times the vector A. Now the results after finding the vector projection of a vector onto another is a vector. So having this in mind, let's solve one example. So for example 3, find the scalar and vector projection of vector B, which has components 9, 0, 4 onto vector A with components 2, 6, 3. So let's solve this question together. Now the scalar projection of vector B onto vector A is given as the component along vector B onto vector A, and that is equal to the dot product of vector A and vector B divided by the magnitude of vector A. Now let's find the dot product of vector A and B. So basically we are going to multiply the corresponding components and then sum them up. 2 times 9 is 18. 6 times 0 is 0. And then 3 times 4 is 12. So we have this all divided by the magnitude of vector A. So that is given by the square root of the square of the x component plus the square of the y component plus the square of the z component. So we have the components of vector A to be 2, so 2 square, plus 6, so 6 square, and then plus 3 square. Now 18 plus 12 is 30 divided by 2 square is 4, 6 square is 36, 3 square is 9. So we have 30 divided by, now 4 plus 36 is 40, 40 plus 9 is 49. So we have the square root of 49, and the square root of 49 is equal to 7. That is, the positive square root of 49 is equal to 7. So we have 30 divided by 7, and basically this is the scalar projection of vector B onto vector A. So now let's find the vector projection of vector B onto vector A. So the vector projection of vector B onto vector A is given as the dot product of vector A and B divided by the magnitude of vector A times the unit vector directed along vector A. Now we have the dot product of vector A and B to be 30, so we just insert that here. So we have 30 divided by the magnitude of vector A is also 7. So we have this times, now we have vector A, that is the components of vector A, to be 2, 6, 3. So we have this divided by the magnitude of A, which is also 7. Now let's simplify this. So this becomes 30 divided by 7 times 7 is 49. So we have 30 over 49 times vector A, which has components 2, 6, 3. Now at this point, we are going to multiply 30 over 49 by each of the components of vector A. So that's going to be, we have 30 times 2 is 60. So 60 divided by 49 30 times 6 is 180. So we have 180 divided by 49. And then 30 times 3 is 90. So 90 divided by 49. So basically, this is the vector projection of vector B onto vector A.